पे भी डाल दें।
ये देखते हैं,
डाल देना।
okay. So first of all, we will take two examples. Let us say a is equals to 1010, b is equals to 0110. So when we add it, so we will have this output 110, 0, 10, 10, 10, carry is 1, right? So we have carry is equals to 1 and sum is given by 1000. So for this purpose we are going to need a 4-bit triple carry adder. Okay, so let me draw it. So in this we will be having inputs like A0, B0, A0, B0, A1, B1, A1, B1, A2, B2 and A3, B3, and the second input here Cin is equals to 0. Then S0, that requires that is a sum 0, and the sum will be given by 4 bits over here, and the 0th part is given by this full adder. Here Cin is equals to 0. Then the carry will be produced here, and this carry will be propagated to the next stage, and this will be input to the second full adder, right? So again we will be having S1 here, then C1 will be produced here. This is C1, and this will be again added here, and in the same way it will propagate here. So we will have S2 here, S3 here, and in the same way C3 here. Okay, here C2 is being produced from this full adder. So for the final delay calculation, generally the question is given in such a way that how much time is needed to produce the output. So generally in this question, output means sum as well as carry. So first of all we need to check which value is changing and which is not. So let us say initially first of all whenever we are solving digital circuits, we will initialize them as 0, the C0, C1, C2 and C3, as well as S0, S1, S2, S3, all of these will be initialized with 0. Okay, so initial value was 0, 0 for this full adder. For this as well it was 0, 0. For this the same value, and for this as well as it was 0, 0. Okay, and let us say for example, let us consider the full adder takes 2 nanosecond to produce carry, and it takes 5 nanoseconds to produce sum. Okay, generally the sum is calculated using XOR gates. So in general the delay taken by that XOR gate is more than that of that carry. Okay, so after considering this, we will again follow up here. So after 5 seconds Oh, okay, first of all, let us check what is the output for sum. For sum, we are having output as four zeros, right? So these four zeros, like we are initially having these values, and after that, our final output is already 0 0 0, and the only part is this carry is changing, right? So the point is these outputs are not changing. That means these values are available at 0 second, right? Because these are not changing, so we can consider that the time required to produce the sum output is 0 second. Okay, and then this C3 value is changing right now. Okay, so first of all we'll see here, for to produce C0 we need 2 nanoseconds from here. So this 2 nanoseconds, this full adder will take 2 nanoseconds, and it will produce C0, right? So after 2 nanoseconds, C0 is produced after 2 nanoseconds, then this will be propagated here. So the point is this is already 0 here. Yes, this value is 0 here. C1, which was 0, which was initially 0, but the point is C0 value here, you can see here what is the carry being propagated here. Whenever we are adding this 0 0, the carry is 0. This is carry part. Okay, carry is 0. Then whenever we are adding here, then carry is 1. Okay, then again whenever we are adding here, then carry is 1 is being produced. Okay, so this is our final result. Pardon me for this less space. So carry 1 is being produced here again, and this is finally producing carry 1. So you can see this value is getting changed, right? So after 2 nanoseconds, this value is same, right? Because no carry is being produced, so this result is also available at 0 second only. Okay, so we can say after 0 second, at 0 second we have all the sum outputs S0, S1, S2 and S3 are available at the 0 second. At the same time, C0 is also available at 0 second. Why are we saying this? Because the value of C0 is not changing, right? If it were changing, like let us say there was a case in which value of C0 was changing, then we could not say that carry is available at 0 nanosecond, right? So since value of C0 is not changing, that is why we are saying that C0 is available at 0 nanosecond. Then C1 value is changing, right? So C1 value is changing, so this value is available at 0 nanosecond, and this full adder is taking 2 nanoseconds to produce the carry. So since this value is changing, so we can say that C1 for C0 we don't need 2 nanoseconds because the value is not changing, so it will be available at 0 nanosecond. C1 is taking 2 nanoseconds. Why are we considering 2 nanoseconds? Because the value of C1 is changing. If it was, let us say there was a case when the C1 was not changing, then we would have considered that C1 is also available at 0 second only, right? So C1 is changing, that's why we have taken 2 nanoseconds. So C1 is available by 2 nanoseconds, right? So the point is before 2 nanoseconds, this after 2 nanosecond it was available, then after 2 nanosecond it will go here. Okay, so after 2 nanoseconds we'll be having here, since C2 is also changing, so after 2 nanoseconds this was available at 2 nanoseconds. Okay, so after 2 nanoseconds it will take 2 more nanoseconds to produce C2 output. This full adder is taking 2 nanoseconds to produce the carry output. So at the end of 2 nanoseconds, this C1 is available to this full adder. So after 2 nanoseconds, we need extra 2 nanoseconds to produce this C2 output. So C2 will take 2 nanoseconds. At this time, C1 was available to the third full adder plus 2 nanoseconds to produce the carry, right? So at the end of 4 nanoseconds, this C2 is available to this full adder, right? So after 4 nanoseconds, we are going to need extra 2 nanoseconds to produce this C3 carry. Why are we going to need 2 extra nanoseconds? Because the value of C3 is also changing. Initially it was 0, and the final value which is being produced is 1, right? So this value is also changing. So for that purpose, we need 2 nanoseconds extra. So C3 is being produced at 4 nanosecond. So we can add 4 nanosecond plus 2 nanosecond required by this full adder to produce the C3 output. So total 6 nanoseconds. Okay, so we can say that C3 is available by the end of 6 nanosecond, and our sum was already available by the end of 0 nanoseconds. So total time required is equals to maximum of these. Let us say this is 0 seconds and this is 6 nanosecond. So we will take the maximum any of these. If it was more than this value, then we would have considered this value. But out of the 6 nanosecond and this 0 nanosecond, 6 nanosecond is greater. That's why we have to consider 6 nanoseconds. Okay. Now we will see another example. Let us say A is equals to 0 1 0 1, and then we have 0 0 1 1, right? So the answer will be produced as 10, and this is 10, this is also 10. This answer is 8, this is 5, this is 3, and this is 8, right? So considering the same scenario over here, let us draw 4 full adders. Okay, so we have 2 inputs here, and one carry is coming from this side. Okay, S0, S1. Okay, I think there is some problem. We will shift it right here. Okay, so you can see it clearly over here. I have made 4 full adders, full adder, right? So in this full adder, you can see the final we have sum is equals to 8. That is, this is my S0, S1, S2, S3. Okay, so as we have already said that at initial values everything will be 0, right? And this is also 0. Everything will be 0 at initialization. Okay, C2, C3, S3, right? And this is Cin. So Cin was 0, and initially everything will be 0 by default. Like for the first bit adder, actually this full adder is working as a half adder only because Cin is already 0, but still for the sake of understanding, all of these are being used as full adder only. Okay, so we will focus on the result again. So what is our output result? Our output result is 0 0 0 1. You can see from here, you can see, right? So we have result here. So there is one thing to notice over here, that S0 has not changed. Okay, S1 is also not changed, S2 is also not changed. Initial and final values of S1, S2 are same, right? The only point is S3 is changing. Okay, so these all 3 values are available by 0 second, right? These are available, but the point is this value is changing. Then we have to consider this value will change only when all of these 3 inputs are available, right? These A3 and B3, A2, B2, A1, B1, A0, B0 are available. I mean these values are available by the end of 0 second, but this value C2 is not available right now. Okay, and you can see the carry part there, 1 1, we have result is 0 and one carry is being produced, that is C0 here. For the sum, if we add 1 1, then sum will be 0 and one carry will be produced. So C0 will be available by the end of 2 nanoseconds. Okay, we have assumed here that one full adder is taking 2 nanoseconds to produce the carry and taking 5 nanoseconds to produce the sum. Okay, so C0 is available by 2 nanoseconds. Okay, so in this result we will also see 0 plus 1 and then there is one carry, so result will be 10 and the carry is also 2 nanoseconds. Okay, carry is also 1, that means the value of C1 and C2, C0 and C1 both are changing, right? So after 2 nanoseconds this was available, and at the end of 2 nanoseconds these two values were available by the end of 0 nanosecond. Okay, but this value was available after the end of 2 nanoseconds. So after 2 nanoseconds this was available. This value is right now not unavailable because this carry has to propagate through all these full adders and then it will come as input over here, right? So this C0 was available at the end of 2 nanoseconds. Then we will again consider it as this full adder will again take 2 nanoseconds. Since the value of C1 is also changing over here, then we have to wait until the C0 is available to this full adder. Okay, so after 2 nanoseconds this will take 2 more nanoseconds to produce C1. So C1 is available 2 nanoseconds plus 2 nanoseconds. Why did we take this 2 nanoseconds? Because C1, which was an input to the second full adder, was available to this full adder after the end of 2 nanoseconds. Okay, and then C1 will be produced by 2 nanoseconds here plus by a 2 nanosecond processing time of this full adder. So finally we are having 4 nanoseconds. Okay, C2. Okay, so this value is available by the end of 4 nanoseconds. Okay, as we already know that these values are available at 0 nanoseconds, but this value was not available at 0 nanoseconds. That's why we waited 4 nanoseconds. After 4 nanoseconds this was available as input to this full adder. Okay, so C2 will take 4 nanoseconds plus 2 nanoseconds, which is the processing time of this full adder, are totaling of 6 nanoseconds. Okay, and in the second scenario we can see this is 1, this is also 0, and we can see C1 and the final C3 is 0. See here, you can see there is one carry over here, right? There's one carry from here. When you add over here, this carry will be the carry of these bits will come here, right? And this will be added with this one, so result will be 0, sum, which is sum will be 0 and the carry will be again generated. So this carry will be added over here, right? So at this point sum is 0, again carry 1 is being generated, right? So at this point, at the end of this C2 is again 1, I mean this value changing, right? But the point is C3 was initially 0 and the final value of C3 is also 0. How? See, one carry is being added to these both of these two zeros, which will produce the sum 1, right? Because there was one carry from these bits to these bits. So 0 plus 0 is 0 plus 1 carry. The sum is 1, carry is 0. So this C3 was available by 0 nanoseconds. Okay, but the point is we would not have been able to produce this if we didn't have this C2 value. Okay, so we can see here C2, see value of this is changing, right? So S3 is changing over here. Okay, so S3 has taken some time. When S3 would be available? If all the inputs of S3 are available and C2 is available at 6 nanoseconds. Okay, so if this is available at 6 nanoseconds, then it will take an extra 5 nanoseconds to produce the S3. Okay, did you got the point? The point is these two inputs are available at 0 seconds, but this C2 is not available at 0 seconds. This C0 is propagated here, then it is propagated here, then it is finally propagated here. At the end of 6 nanosecond, this value is available, C2 value is available to this full adder. So after 6 nanoseconds, it will take further 5 nanoseconds here. Can you see this? Okay, sorry. This will take another 5 nanoseconds to produce the sum. Okay, so finally what will we have? The S3 will be produced by this 6 nanosecond plus 5 nanosecond to produce it, right? This delay was due to this carry C2, and this 5 nanosecond was the processing time of this full adder to produce the sum. So total it was 11 nanosecond. So you can see maximum time which is being required by this full adder to produce C2 is 6 nanosecond, and then we have another S3 which is 11 nanoseconds. So we have to consider maximum of this. So maximum we are having 11 nanoseconds, which is the answer. Okay, you can send me some of the examples whichever you are finding difficult, and I can solve it for you and make you another video for that. Thank you.